Hello everyone, it's August 29th. Let's hope we can continue on yesterday's trajectory and get a good one out of this. We did pretty well yesterday. Alright, given a sorted integer array and an integer n, add patch elements to the array such that any number in the range 1 to n inclusive can be formed by the sum of some elements in the array. Okay. Add a patch elements to the array such that any number in the range 1 to n can be formed by the sum of some elements in the array. Return the minimum number of patches required. Okay, so we have 6, so we want 1 to 6. So how many numbers need to be added to this such that their sum can be from 1, 2, 3, 4, 5, 6. So currently we have 1, 3, 4. If we patch 2 to the numbers, then we have all this 1, 2, 3, 4, 5, and 6. So we need one patch. 20. 1 through 20. So we need to have two patches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah, 10. And actually, no, 10, 11, and 12. Well, that's the same because we have 10. So, okay, hold on. Did we find a pattern here? So the pattern we find is 1 produce 1, right? 1, 2 produce 1, 2, 3. 1, 2, 3 produce 1, 2, 3, 4, 5. 1, 2, 3, 4. Actually, not 1, 2, 3, 4. 1, 2, 3, 4 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That gives us 1, 2, 3, all the way to 10. But what about 1, 2, 4, 5? 1, 2, 3, 4, 5, 6, 7, all right, 8, 9, 10. That gives us 1 to 10 as well. Actually, give us 11 as well. 11 and then 12. Oh my God. 1, 2, 4, 5 give us everything. Holy moly. 4, 5. Oh my. That is actually interesting. Like 1, 2, 3, 4 give us 1 to 10. But 1, 2, 4, 5 give us 1 to 12. Oof. 1 to 2 give us everything. Huh. Yeah, it already gave us everything. Oh. The number is 1,000. A number is sorted. And there's no hints. Wow. I don't know. Oh, wow. Um, I mean, how do we approach this? We'll have 1. All right, let's do this. Because it's 1 to n, right? So n is the largest one. Therefore, to get 1, the only possibility is to have 1, right? So if the original doesn't have 1, we have to add 1 no matter what. Okay. Now, to get 2, right? How do we get 2? Well, if 2 exists, that's good. If 2 does not exist, then we need 1 and 1 to get it 2. But that's the only possibility to get it 2, right? Either 2 exists or we need 1 and 1 to get it 2. So let's say we have 1, we don't have 2, and then we have 2 options, right? We have 2 options. We can either get a 2. Yeah, we're considering like we don't have 2. If we don't have 2, in order to get to 2, we need to have either we need to add a 2 or we add another 1. Now consider 3. The same thing. If we don't have 3, then we can add a 3, right? Or we can, now 3 can be formed by 1 plus 2, 1 plus 1 plus 1, or 3 by itself. Which means if we already have a 2, yeah, so for 3, because 1 plus 2 and 1 plus 1 plus 1 is the same thing. It's just if we have 1 and 2, then we can generate 3, right? If we have 1 and 2, then we can generate 3. Okay, let's go back. 1, we have to have 1. There's no question. There's no other way. So we have to have 1 if we don't have. And then for 2, we say we can either have a 1, or we can have another 1, or we can have a 2. We can say that, oh, but it also depends on if it got used. Huh. Let me just generate any number, right? Any number. Any number can be generated by all the values that can be generated before, right? Any value, like a 10, can be generated by the sum of, like, let's just say we go through the n, right? As we go through the n, and we will have to, if the value is larger than the n, then we definitely don't use it. We use all the values smaller than the current value we're looking at. Those are the values that can form the current value, right? Like in this case, we start from 1. 1, we're done. 2, so 1 is done, we can move on to the next one. So 2, what we're looking at currently is 5, so we don't have 2. Now, if we don't have 2, what we need is the values below 5 to generate a 2. And we have 2 options, right? We have 2 options. So start from 1, 5, and 10. So we're currently looking at 5, and then we don't have 2. So 2 options. We either added 2, right? We either added 2, or we add another 1. So let's say we added 2, right? We added 2. And now we added 2, we become 1, 2, 5, 10. I have 1, 2, 5, 10, and 2 we're done. So we still keep at 5. Now we want 3. Now to get 3, we need previous to generate 1 and 2. Or we can add a 3. But don't want to add because we want a minimum number of patch. So look previously, can we get a 1 and a 2 independently? Alright, which means getting a 1 will not, or getting a 2 will not affect getting a 1. So how do we check for that? We check for which values need to be used to generate for each number. And we go through them. Go through them. If I can know how 1 is formed, right? So if I can know how 1, let's say 1 is formed by using index 0. Index. Now we're incrementing or expanding, so the index is changing. We'll worry about this later. Just say we have index, right? 2 is formed by index 1. Yeah, the 1 we have already processed. Those values index will not change because we always add small values. Okay. So in that case, we need to form a 3. So let's say 3, we need to form a 1 plus 2, right? That's how you do 3. And we check for 1, the formation of 1, because we know we at this point we're already formed. Like everything can be formed. We just need to know whether the form have overlap, right? Whether the values required to form 1 and 2, they overlap. And if they overlap, then we cannot use it. We have to add a new one. If they do not overlap, then we can use them to create the current value. So now we see, okay, 1 is formed by one value and 2 is formed by another single value. There's no overlap. So say 3 can be formed, so we don't have to add anything to it. Okay, so 3 passed. Now we'll go to 4. And we're still pointing at 5, right? So 4, okay? So we need 4. Again, we go, so 3 will be formed by 0 and 1, right? Those are on the 0. And we say, okay, how about 2 and 2? And 2 and 2 we cannot do because they will overlap on 1. So 4 cannot be formed by the combination of any of the previous values. So we have to add 4. So okay, we add 4. So it become 1, 2, 4, 5, 10. Right? That's when we add 4. We cannot be, hold on. We cannot be formed, but we can add 4 by adding another 2. Right? We can add another 2. We don't have to add a 4. Like, we can also add another 3. Yeah, oh my god, do we, like, bifurcate here, right? We can say, we can add another 2. Then we have 2 and 2, right? We can add a 3. So we have to add 1, so we can add a 3. right? We can also add a 4. We can add, so there are 3 situations we can add one value, right? We add 2, we can get 4. We add 3, we can get 4. We add 4, we can get 4. So we bifurcate. Okay, next 5. 5, we have 5. Next 6. So each one is formed different. So 6, we can form 6 for all of them because 1 plus 5 is 6. Okay, 7. 7, we can form 7 for all of them. Okay, 8. 8, we can form 8 for all of them. 9, we can form 9. And we can form 9. We can form 9. 10, we have 10, right? So now we formed all of them. 11, well, we have 10, right? We have a 10, and a 10 is by itself. And then, so the previous one can form from 1 to 9. So we are good for 11, 12, all the way to 19. Now the question is 20, right? Question is 20. Now 20 require the rest to form a 10. 1, 2, 2, 5, is that the 10? That's a 10. 1, 2, 2, 5 is a 10. 1, 2, 3, 5 can form a 10. And 1, 2, 4, 5. So there are 3 possibilities for this, and all of them adding 2. So we can add a 2, 2 will work, right? A 2, 2 will work. A 2, 3 will work. And a 2, 4 will work. Okay, it can be. How about the other route? So initially we say 2 is going to be formed 1, 1, 5, 10. Now we add 3. When we add 3, we need to have 1 plus 2. And then 2 is formed by 1, 1. There's overlap, so we cannot. We have to add either a 2 or a 3 or a 1 again. Right? We have to add 1 again, or 2 or 3. Let's add a 1, we get a 3. Add a 2, we get a 3. Add a 3, we get a 3. Now 4. This one pass, this one pass. This one have to keep adding, so we say, no, this one's not going to work. Because at this stage, we already have to add more. So we say, okay, we don't consider this anymore. 5, okay. 6, okay. 7, 7 is okay. 8, okay. 9, 9 is okay. 10, 10 is okay. Okay, so that can also form, but 1, 1, 2, 5, 10, the maximum it can form is 19. So this one cannot do 20. So this one eventually we cannot do anymore. But 1, 1, 3, 5, 10 is possible, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, 1, 1, 3, 5, 10. That's another one. Oh wow. How? It feels very, very convoluted. I still have no clue. So what are we? Like even the checking, right? The checking for each value, we have to check all possible. I mean, we know, right? At a certain value, we know every value previous smaller can be formed by the sum of the array values. But what we do not know is whether they overlap. And in order to check for overlap, we have to go through all possibilities. That's a lot. Talking about this value, 2 to the 31st minus 1. Well, not necessarily. Not necessarily, right? Because when we check for 11 and we have a 10, then it will be the same. Then we can just we'll have a 10, right? And we know, yeah, when we have a 10, then when we reach 10 and we have a 10, then we are sure that we can reach at least 19, right? At least 19. Then what? And 20, okay. How about if we keep going, then it's too small. Then we add another 10, right? It's too small, we just add another 10. We add another 10, that can reach us to 30. So every time we add another 10, until we hit something big. Hold on. Until we hit something, like before we hit something big. And once we hit something big, the dynamic changes, right? If we hit something, if we can build up to a certain value, let's say we have a big value in the nums, right? We'll call it k. And we can build up towards k. Then we have all the values that can be represented from 1 to k minus 1. Right? From 1 to k minus 1, we are able to represent by all the values before this k. And now when we add this k, then we are able to represent from k all the way to at least 2k minus 1. Right? That's what we can do. Actually, if we have the capacity to find all the values that can be represented by the previous numbers, and then we have all this, right? Which means we can represent from 1, actually from 1 to, let's say 1 to p, that can be represented by the first few values. Okay, and then every time we add a new one into it, then what we can represent is, now we can expand the total value that we can represent, right? So every time we add a new value, we can expand the range. We add a new value to expand the range. And if the expansion includes this value, then we're done. Let me try it again. Let's do the first one. 1, 3, and 6, right? So we have a 1, 3, and the target is 6, right? So we start from 1. 1 we can only extend to 1. So the current extension is 1 to 1, right? And then if we just do that, let's say the next target, this was 1, so we want is 1 to some values, right? We want 1 to 6, but now only 1 to 1. So let's how about 1 to 2, right? 1 to 2. If we 1 to 2, let's say 1 to 2, we can add a 1, right? We can add a 1. If we add a 1, then our range is 1 to 2. But if we add a 2, right, our range will become 1 to 3. 1 to 3. So add a 2 will expand our range, which is a good move. So we add a 2. Now, once that's done, then we have incorporated 3. So we can actually keep moving. We can go, just keep going until we, so we can expand all the way to 3. So every value that's in the array that's smaller than current end range, we don't have to incorporate anymore, but we can use that to expand our range. So 3 is inside our range, so we don't have to worry about it. We're going to use 3 to expand our range. So we have 1 to 3 already, right? We can do 1 to 3. Now we can add a 3 to it. So our range gets expanded. So we can do 1 plus 3, 2 plus 3, 3 plus 3. So our range becomes 1 to 6 after adding the 3. And that already incorporates 6. So we're done, right? So we only add 2. Then we are good. Okay, in this case, we start with 1, right? And our end range is 1. So the next one we're looking at is 2. The end range doesn't include 2, so we have add 2. Okay, next one is 3, right? 3. And next one is 3. And the end range covers 3, so we can skip it. The next one we're looking at is 4. And the end range doesn't include 4, right? Because the end range currently is 3. So it doesn't include 4, so we have to add 4. So we add 4. But by adding 4, our end range becomes 7. So we can go all the way to 7. So next one's 5. 5 is already in it anyway. So if the 5 is already in it, right? So we don't have to add. So 5 was already in it. So we include it, and that increased our range to 12. So we can go all the way to 12. And then next one is 6. 6 is within the range, and it's not in there, so we don't add. 7 don't add. 8, 9 don't add. 10. 10 is within the range, but it's inside this, so we can add 10. That boosted our range to 22, right? And then boom, we already hit our target. All right? We already hit our target. Now, this is interesting because what I can find out is 1, 2, 4, 5 extend our range to 12, right? Which means if I have 1, 5, 10, and our target is 13. That's an interesting question. If I have 1, 5, 10, right? If I have 1, 5, 10, and our target is 13, then we need to do 1, 2, 4, 5, which extend to 12, but it's not enough, so we have to add, right? So, oh, hold on, we already include 10 because, hold a sec. I think I'm almost there, but the end range, right? So the end range, after including 5, the end range is 12, right? The end range is 12. So what do we do? And then currently our target is, now we're looking at 5, right? So then we should look at the next value, right? Next value is 10. 10 is included, so it gets expanded. Let me do it one more time. Let's do the 1, 2, 2, 1, 2, 2. So we started with 1. The first value is 1. So yeah, if 1 doesn't exist, we have to always add 1. Right? There's no question about it. The first one is 1. That's good. And then we say, okay, next one we're looking at, so the current range is 1. and we look at the next value. Let's just look at the next value, right? Next value. Next value is 2, right? And 2 is outside of our range. Therefore, what would be the best way to iterate this thing? No, we have currently 1, right? So we need to extend our range to 2, right? We want to extend our range to 2. So the next range we're looking at is 2. So, but the current range is 1, so it's not enough. So we need to either add a value or incorporate a value. So we first check incorporation, and we can incorporate if this value is smaller or equal to the current range. The current range is 2, and this one is smaller or equal to, so we can incorporate. And after incorporate, we can expand our range based on what previous we had. So we can expand the range is 3, right? Range is 3. Now the current range is 3. Then what do we do? What's the logic here? The current range is 3, and so we can current cover to 3. So we can actually search in this, and we can actually keep iterating, right? Keep iterating. We keep iterating the array to find the next value. If it's smaller than the range, then we can incorporate it. So we have the range, right? And then we go to the next value. If it's larger than our range, then we need to figure out, like, if the next value is larger than my range. If the next value is 1 large than my range, then just incorporate. If the next value is too big, then we need to add the next. Again, so we start with 1, right? With range to 1. And then, so we know the current range. And we have the current range, and we have the current range. So we move the next position in the array, and we check. If the value is smaller or equal to my current range, we incorporate it and expand our range. Then we look for the next one. Okay, that one's good. If the current range is smaller than, so we move to the next value. The next value is larger than my current range. Then I incorporate the current range plus 1. I incorporate it, right, and expand the range. So I have a new range, then we do comparison. Okay, let's try that. Let's try it. What the hell is this? Alright, let's do this. Okay, so don't need any of these. Let's copy and paste this. Alright. So what we're saying is the end range, right? So the number to patch, res equals 1 if nums 0 is not equal to 1, because if you don't have 1, you must have 1, else 0. The rest is the number to be patched if the smallest value is not 1, then we must patch 1. Otherwise, we cannot get 1. So if it's not 1, we must patch 1. Otherwise, if we have 1, we don't have to patch in the beginning. Now we have end range currently is 1. All right. And then what do? We need to iterate, right? So in fact, what we can do is the res and index, right, is going to equal to 1, 0, if this, else 0 and 1. This is saying if the first value is 1, if the first value is not equal to 1, then we have to add 1. But our starting index is going to be 0, right? If the first value is 1, then our starting index is going to be index 1, which is the second value. And because I set the first value is 1, so the current end range is 1, right? Now what we're going to do is so while end range is smaller than n, and index, index, that's interesting. An index, it is possible that after adding the last one, then the index, maybe we don't have to consider the index. We'll go for the next index, right? And if it's too small, then we just keep going, right? And let's do this. I index is smaller than len nums, right? So these are the conditions. And what do? So what we do is we compare the current index, current value, to the end range. We say if nums index, right? That's the current value we're looking at, right? Current value we're looking at. If this value is, let's say, smaller or equal to end range, then what we do is we increment the index because we incorporate it, and end range plus equal to nums index, because we can add that can expand our end range, right? So we expand our end range. And by doing that, we don't change our result because this one's already incorporated, right? And then we go again, and if it's still good, we keep going until we cannot, right? Until we cannot. If we cannot, that means the current value is bigger than our end range. Then what do? Then, if it's bigger, then we need to add, right? We need to add. So we need to add a value which is 1 larger than my current end range, right? So what do? What we do is we're gonna say end range plus equal to end range plus 1. So we add end range plus 1 as the value, right? We add this value to the end range. So we expand the end range like that. And then, but we don't change the index, right? We do not change the index, but we expand. And that's when we res have to plus equal to 1. That's the value we added. Now once we add that, we expand the range. This is like greedy. I feel like this is greedy, but can we have like a proof like this is the minimum number? Because this is the optimal strategy, right? Like if a value, yes, this is optimal strategy. Is when a value is cannot be represented by the combination of the previous numbers, right? When I have a value that cannot be represented, then there are many ways. to incorporate this value. We can like this, right? We don't have a 2, right? Now we can add a 1, we can add a 2. There are 2 ways, but what we want is to add the minimum. Therefore, each new value that's getting incorporated, we want to expand the range as much as possible. If I add a 1, then the range only expanded to 2. But if we add 2, the range expand to 3, right? To 3. So adding 2 is a better strategy than adding 1. Therefore, we always add the end range plus 1. Just add a little bit. Just add a little bit. But then that we can expand the range, right? Expand the range. And then rest plus equal to 1. And then go back up, right? And then blah, 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 blah. Once we exit from this, then we need to check, right? We need to check. There are 2 scenarios. We say, well, if n range is larger equal to n, then we return rest. We're done, right? If not, that means we index has been exhausted, but our n range is still not reaching n. Now, in that case, we basically run this again, right? But maybe it's possible. What if we say or? Well, I think it's fine. We just n range is smaller than n. We'll just run it again. Like if when this comes out, we do it again, right? Do it again. Actually, it's fine. We don't have to, right? This is when, like, if index, right? Let's say if index is smaller than this, right? If index is smaller than this and this is smaller than, then we do this. Else, it could either be index is larger or the number of this is larger. Then we need to do this, right? And range to increase. And if we go already exhausted all the index, right? We exhausted all the index and it's still not good. Then we go back and we always just add 1 more. And okay, we cannot add 2 more because if I add 2 more, we don't have n range plus 1. So we add this and then try and then turn the rest. All right, let's give this a shot. We have a couple of test cases. For instance, we have 1, 3, and 6. Return 1. We have 1, 5, 10, 20. Return 2. And the last one we have 1, 2, 2, 5. Return 0. Okay. And this is going to be nums, and this is main patches, nums, and all right, run it. List out of range. I think if this, I think this one shall go first. Alright, so we passed the first 2, but we failed the last one. Why did we fail the last one? Well, I said if num0 is 1, rest is 0, index is 1. And n range is 1, yeah? And I say index is smaller, yeah? And nums index is this one, as smaller or equal to range. I think it should be smaller or equal to the current range is 1, right? And the value we want is 1 plus 1. So it shouldn't be smaller or equal to n range plus 1. Right? So this is the current n range, and we're checking the value. If it's smaller or equal to, No. It's not. If it's smaller or equal to n range, then definitely we do all this, right? But if it's smaller or equal to n range plus 1, then we incorporate it. Yes, it should be plus 1. Because n range is 1, right? And then the next one we want to do is to make it n range become 2, right? So any n range, and we're checking the value. If the value is, because see, we're adding n range plus 1. So if the value is already n range plus 1, we don't have to add. We just incorporate it, right? So if it's smaller or equal to n range plus 1, we just incorporate the value. We're incorporating this value. Yeah, we're incorporating this value. Otherwise, we have to do this. All right, let's try this. Let's try pending. Pending. That's a long pending. Judging. We passed. Wow, that's 2 days in a row. 2 days in a row. I'm on fire. I am on fire. Thanks. 2 days in a row. Hard question. Solved for 45 minutes. Well, technically 46 minutes. It's the best performance of my all of this. Is the best weekend. I mean, I have passed both tough questions in the past and over the weekend, but I think that time we had a question that I have encountered before. This time it's too fresh. Two fresh, hard questions we were able to figure out. I am impressed by myself. All right. The runtime. What is the runtime? Holy guacamole, what is the runtime for this? Because each time we are adding this to the n range, so n range is leaping forward, right? N range is leaping forward. I do not know. I honestly have no idea. Depends, right? So every time we add something, we add something, we add something. Well, we go through each index. We will go through each index. Now the question is, how many of this we need to go through? I mean, it's going to be ON. Anyway, let's check the time. Let's check the time. Well, 60 milliseconds, and we go in the middle. Yeah, I don't know. I don't know the time complexity. I mean, we have to go through each index, so the length of nums, if we call that M, OM is definitely, we have to do OM, and the rest is just how many more times we have to it's double, right? I mean, the worst case scenario is we're provided with 1 and the n is 2 to the 31 minus 1. That's the worst case scenario. But in that scenario, what we're going to do is 1, 2, 4, right? 8. So it's log n. So the worst case scenario is OM. No, it's O log n. What is the... Yeah, I think it's log n. I think it is log n. Because this, we won't like including all of the, we don't have to go through all the nums, right? We just keep incorporating. and incorporating, and then now we do have to incorporate it. I think it will be either OM or O log N. I mean, yeah, I don't know. I honestly don't know. All right, let's write the summary. So this is greedy. This is greedy. I think this is greedy. I think this is greedy. So the basic idea is that given the first given given the first few elements, how do we say? Let's say, okay, let's do this way. Let's say we are currently looking at nums I, right? That's the one we're looking at, and we know that after some incorporation, after some patching, nums 0 to I has a range, can represent all the values from 1 to k. Right, we call k the end range, the end range. If nums I, right, is within k, then we can incorporate nums I without doing any patching, right? Without doing any patching is smaller or equal to k plus 1, then we can incorporate nums I without any patching, right? Without any patching, right? Without any patching to reach at least, to have the end range reach at least k plus 1. And after incorporation, our new end range will be k plus nums I. Now this is the most important insight, right? We can expand the range. We can always expand the range just by adding the newly incorporated value to the previous end range. If nums I is bigger than k plus 1, then our current range cannot cover the values from k plus 1 to nums I. Therefore, we need to patch a value. Here, there are many ways to make the patch, right? Because many values, right? Because many values can be used as the patch to increase the current end range above nums I. However, there is only one value that can increase the range maximally, right? And that value is k plus 1, right? I want to k plus 1. On k plus 1, we can satisfy the k plus 1, but we can maximally increase the range. In order to use minimum, in order to achieve minimum patch, we want each expansion, right? Each expansion of the range to be the largest possible. Therefore, we always patch k plus 1 when k is smaller. Oh no. I can go. I can go, yeah. I'll go right now. That is so stupid, always deliver to the other building. Don't leave a bad review on the delivery. Yeah, I already did. People think we're stealing, but we're not stealing. We deliver it wrong. Oh, someone's stealing? No, I'm just like, some people might see. And they're like, oh, you guys stealing. It's not stealing. And don't delete that email with that picture, just in case. And people are saying we're stealing things. Yeah, we just had an issue. The Amazon delivery people delivered our package to the wrong door. And now we have to go there and take our package. And it feels like if people don't know the situation, they think we're stealing. Those people. Well, I shouldn't blame them too much. But it's a hard job delivering. Mistakes happen. Well, it happened a bit too often though, but what can we do? Alright, where are we? We always patch this when k is smaller than num. Yeah. And we continue expanding, right? Continue expanding the n range until it is larger than the target n. The time complexity is I would say OM plus log n, right? Where m is the size of the input array and n is the target. That's my current take, because we have to go through every index. That's OM, right? And along the way, we will have to do a bunch of this. That's maximally will be O log n. So that's why I say OM plus log n. And we run at 60 60 milliseconds. So 60 milliseconds or 68% ranking. All right, let's take a look at the solution. I think we hit it on the nail, right? I think the solution will be almost exactly the same as what we have. 330. That's the question. So LeetCode 330. Well, I thought I clicked on it. Yeah, so just by experience, right? LeetCode, difficult question, or not. It's not going to be a lot of code. Like this one, if you think about it, you're trying to really arrange combination. No, it's just the idea of doing that, like that whole cluster crap you have to deal with. That's not going to be the solution. The solution usually is very, very elegant. Very elegant. Let's see, what is you can make array greedy. Exactly, that is greedy. This is greedy. Two solutions: merge intervals plus greedy. Merge intervals and times log n. Oh, on. I think they say it's on. I think this is the same. If this and this plus equal this reach equals 2 times v plus 1. Yeah, that's exactly the same, almost verbatim. But the complexity is on. I don't know. What does n stand for? Let's read this one first. On the smallest number, add them one by one and always keep the possible range of numbers we can get in the form 0 to k. It is not union of interval, but only one interval. Let's go through this example. I did not choose any numbers yet. Are we missing if we take number 1? No, let's take it. Now we have interval this. Missing something. Yeah, it's the same. Missing something if we take, yes, we're missing. Well, we need to take the next patch equal to 8. So now we have 8. Now we don't miss. Or we can take 13. I'm missing the 29. So we add 29, and we're done. All right, what is the first one? Keep all possible numbers we can get as a list of intervals. For example, all possible numbers we can get as a list of intervals. 0 to 2, 4, 5. Then we add a new number, and we can merge our intervals. What numbers do we need to add? We need to add number 3 and smallest possible number, which are not in our array. Merge interval. Oh, we've done merge interval before. We sort by the start, and we check each interval. Not merged, or merged is smaller than interval 0 minus 1. Yeah, so the merged, if the end is smaller than, then we can merge, right? We can merge dot append. We can merge. Otherwise, Otherwise, hold on, wait. It's smaller than, oh, this we cannot merge. This we cannot merge. Otherwise, we merge. Yes, let's merge. And then we will do whatever this is. The num is in num, so we're going to merge it. This plus this plus this. And self.merge ints plus the new one. That's the new one. Wait, hold on. For everything in it. I think what it's trying to do is create this thing. So we get each one out. Probably 0, 0, 1, 1, 2, 2, 3, 3, right? That's what it is. And for num, yeah, for num, and ints is the previous, right? And I want to plus, if we add the new ones in, so everyone will get I don't understand this part. For ij in ints is all these range, so current range, right? And then we say we have a new number coming in, and everybody gets expanded. Oh yeah, everybody get expanded. Everybody gets expanded. Huh? All possible can get as a list of intervals. List of intervals. What do you mean, list of intervals? So initially it's 0, 0, right? So it's a 0, 0 plus first number is 0, 0, 0, so merge it to 0, 0, and then 1, go 1, 1. Now 0, 0, and 1, 1 is, we can merge 0, 0, and 1, 1, so that will merge, it will be like this. Click on 0, 1. Now a new value comes in. A new value comes in. So previously, our range is 0 to say 0 to 1. And then new value 2. 2 comes in. So 2 comes in, I say the range can be 2 to 3. Right? So by adding a new value, we can expand to 2 to 3. And we need to merge them together. Okay, I started getting it. And then that'll be 0 to 2, right? 0 to 1. Hold on, that's not 0 to 2. Yeah, I don't understand. Oh, it's intervals. What is interval? Keep all possible numbers we can get as a list of intervals. All possible numbers we can get so far. So all possible numbers we can get is 0 to 2, 4 to 5, and 12 to 12. That's all the possible numbers we can get, right? And then 3 is missing, so we have to add 3. But how about all the others? This is something I don't understand. That's like previous intervals and plus the current number. Let's say I can get, so all the values we can get from the previous interval, right? And then by adding the new value, oh, okay, that makes sense. That makes sense. Okay, I see what this is doing. So by adding a new value based on what we can get previously, we have a range. By adding the new value, that's the new range we can get, right? We can get. And then we merge them, so we get a new interval. So these are all the values, all the ranges we can get. So every time a new value comes in, so we expand, right? We expand, yeah, we expand, and merge, and then we get the entire intervals. Okay, now what we say is intervals 0, 1. Intervals 0, 1. That's correct because we want the largest interval from 0 to the end. Okay, that's cool. If it's smaller, then we need to add. What value do we need to add? We say for ij in ints, all the intervals, I plus, that's the end. So each interval's end, right? Each interval's end plus 1. We add that value. Yeah, we add the value just slightly larger than us, right? So we create that and plus that, and we merge. But hold on. How many you're doing? You're adding a bunch. You're adding a bunch, right? So if I have lots of intervals, then I'm adding a lots of them. Why don't you just patch plus equal 1? Right? You're doing everything in the interval, and we're adding the last value inside, and we're adding 3. We're also adding 6, and we're adding 13. We're adding all of them. And we add them, and then we do the merge, right? We merge. And patches plus equal 1. I don't know about this. This feels not right. We're adding that many at each round. And what if we have to go the second round? And what if we need? Let's see if we can produce a counterexample. So let's say 1, 1, 1, right? That's 0, 1, 2. That's 1. That's not considered 0. 0, 1, 2, and no 3, and we have 4 and 12. 1, 1, 4, 12, right? 1, 1, 4, 12. We can get 1, 2, no 3, 4, 5, and 12. Well, actually, we can get more than 12. We can get 12. No, it's not going to be 12. It's going to be 6. 1, 1, 4, 6. Right? 1, 1, 4, 6. That is the range we have. Like 1, 1, 4, 6. We get 1, 2, 4, 5. Oh, well, 6. That doesn't make any sense, huh? All possible numbers we can get as a list of interval. No, I don't think this is right. and then pass all of them? Let's see. We start from 0, 0, right? So let's use this as an example. So what we get? So we start with the 0, 0, and the first value, what we get, so we have 0, 0, and 1, 1. And we merge it. That will become 0, 1. And then next one is 5, which will have 5, 6. So that's 5, 6. We cannot merge. And the next one comes in as 10. 10, we have 10, 11, 15, and 16, right? And then none of them can be merged. So 10, 11, 15, and 16. So that's after the first round. That's what we get. And now what we need to do is to find what we need to add into this mix to make it work. Oh, we also have 0, 0 in there. Oh my god. Hold on. That's not right. So we have 0, 0 after the first 0, 0, and 0, 1. Oh no, 0, that's 0, 1. Yeah, that's right. That's true. That's 0, 1. And then 5 comes in. We'll do 0, 1. So 5 and 6. Yeah. 0, 1, 5, 6. And then 10 comes in. So 10, 11, and 15, 16. That's what we can get from initial. And then we say for each one, right, we add a new one. So what we do is we add a ij plus ints. Oh, ints 0. That's the thing. Ah, so we only add the first one. Ah, okay. So say everybody, we're gonna add the end range of the first one. So now we can expand by adding one value, and then we merge. Oh, I see. Now it makes sense. Now it makes sense. It's just a bit convoluted, right? We don't have to consider the entire range. We just need to consider the end range. And I'm not going to call this one. I'm going to keep this one in my head, and that shall be it. All right, I think that's it. That's it for today. 7 short lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10. Ah, that doesn't count. Alright, anyway. That'll be it. That'll be it for today. I will see you guys tomorrow for an easy question. Maybe I'll get stuck tomorrow. Adios.